Hello, welcome to yet another episode where we shall be looking at the proposed memorandum of the paper to mathematics June examination for grade 12, 2025. Okay, so within this paper, we have a well-structured paper whereby the answer book is also merged with the question paper. So the paper had 9 questions. We apologize for the quality of the paper today, but we shall work with it, okay? So only answers will not be given full marks, meaning that we have to show our calculations and workings, okay? Information page with the formula will be included at the end, necessary round of 2 decimals. Okay, and then candidates may not retain a question paper or remove one from the exam room. Okay, all right. Then we have a lot of instructions here, but that's not the business of the day. Question number 1. We're being told that in the diagram below, ADQC, okay, and DPB are straight lines. Okay, so this and then this are straight lines. Okay, this is a point on the y-axis. A and B are points on the x-axis. The equation of BC is given as this. And then the equation of AC is given as this. It's further given that P is that, Q is that, and then T is that. Then the distance TP is given as that. Okay, then 1.1, they want us to get the gradient of PQ. So whenever a question asks us for the gradient, we know that gradient is given as the change in y over the change in x. Alternatively, you can tell us the y2 minus y1 over x2 minus x1, okay? So what I'll do, I'll say 3 minus 1, okay, over 7 minus 6. So 3 minus 1 is a 2 over 1, which is the same as a 2. That should be 2 marks, okay? Then they're asking us, why is PQ parallel to BC? Why is this line parallel to that one? Now, since we found the gradient here to be 2, we know that when lines are parallel, the gradients must be the same. So we're going to say that the gradient of BC is a 2 from the equation, meaning that the gradient of BC is also the same as the gradient of PQ. That's the kind of explanation. We must give a reason. So we're going to say that they have the same gradients. Okay. The lines have the same gradient or equal gradients. Okay, so that is 1.2. Then 1.3. They're telling us that if Q is the midpoint of DC, we must get the coordinates of C. If Q, this line, this point, is the midpoint of DC, then we need to find the coordinates of C. So we don't know the coordinates here. So that is X and Y. We can get the coordinates here from this equation, whereby we know at D, X is a 0. If X is a 0, then Y is going to be a 2. Alternatively, what we can do is break down or rewrite this, meaning that 7y is going to be x plus a 14. Let's divide through by 7. We have 1 over 7x plus 14 over 7, which is a 2. So meaning that D is going to be 0 and 2. Okay, with our midpoint, so we're saying that D is 0 and 2. And then we see Q is 7 and 3. We're seeing C as X and Y. Let's use the midpoint formula that talks about X1 plus X2 divided by 2 must give us the midpoint, which is a 7. Okay. Same story with Y1 plus Y2 divided by 2. We must get the Y coordinate of the midpoint. 3. So let me do the substitution. So X plus 0 divided by 2 must give me a 7. When I cross multiply, meaning that our X is a 14. And then Y plus 2, this Y and this 2. Divide by 2 must give us this 3. Cross multiply, Y plus 2 is a 6. meaning that y is a 4. So the coordinates of C are 14 and 4. Okay, and then 1.4, they want the size of ACB. Where is ACB? So A, C, and B. So this angle here. So with that, I can use the angle of inclination, okay? I can find the size of beta since I have my gradient as 2. Then I can find the size of theta since I have my gradient as 1/7 from here. All right, so we know from that inclination method to say that m is equal to the tan of theta, okay? So for us to get theta, we said it's 1/7 equals the tan of theta, meaning that theta is the arctan of 1/7. All right, so let's punch that shift tan, 1/7, getting a small answer, which is 8,13 degrees. Then for beta, we're gonna do the same thing. M is equal to the tan of beta. So our M was a 2 because the tan of beta, meaning that beta is gonna be the shift tan of 2. Beta becomes 63,43 when I punch this into my calculator. All right, so for us to get the angle of interest, we know that this beta is an exterior angle, which must be the sum of this angle C and then that angle A. So we're saying that A plus C must give us beta. Okay, A plus C must give us beta, meaning that the C of interest will be 63,43 minus 8,13. When I do the subtraction, I'm getting 55,3 degrees. So that is what we had to do for 5 marks. But why did they give a lot of space? To give people an impression that there's a lot of work to be written. Okay, but we understand they are being generous so that if, let's say, learners make any errors and mistakes, can just cross out and write in some extra space. Okay, then 1.5, they want us to get the area of BODC. Let's see, BODC. So when you talk of B, O, D, and C, looking at this entire shape here, this quadrilateral. So there are 2 ways to it. One, we can use what we just calculated, the 55, it's 3 degrees, because that's what we got. Whereby we can get the distance CD, get the distance CB, use your area rule for this triangle, and then get the area of this right angle triangle, and then you plus them together, you're gonna get an answer. What I believe is the quickest way. Okay, I'm trying to avoid decimals. I'm going to look at this entire big triangle ABC. So if I get the area of ABC, I subtract the area of ADO. Okay, whatever I get will be the area of the quadrilateral. But this approach of mine comes with some conditions whereby I need to get the coordinates of A and I also need to get the coordinates of B. So with A, we know that this is the x-intercept and we have this. If we replace x with a 0, no, y with a 0, y is with a 0, meaning that our x is going to be negative 14. Okay, so we shall come down here and say that if y is 1/7x plus 2, we said y is a 0. 1/7x plus 2, move the 2 that side, so negative 14 is going to be x, meaning that a is negative 14 and 0. Same story with the b, coordinates of b. It was a 2x minus 4, if I'm to remember correctly. Let's not guess here. It's 2x minus 24, sorry. So 2x minus 24. So if it's a minus 24, I'll equate it to 0, move the 24 that side. 2x is 24, meaning that X is 12, meaning that our coordinates of B are going to be 12 and 0. So if that is true, I'll go back and say that if that's a 14, and then this is a 12, so the total distance for my base is going to be a 14 plus a 12, okay? And then my height is going to be the Y value of the C, which we got as what? As 4. So I'll say that the area of ABC, okay, is going to be a half. The base is 20, is it 14 and 12 is a 26 multiplied by the height, which is 4. What does this give us? It gives us a 52 units squared, okay? So that is the entire big triangle. Then when I come and look at this small triangle here, it's right angled because this y-axis here. And since this is the y-intercept, this will be 2 units. This will be 14. So a half of 14 times 2, which gives me 14 units squared. Then I need to do the subtraction. So area of BODC is going to be my 52 minus 14. Okay, 52 minus 14, we must get something like 38 units squared. Okay, so that is how I would have approached this, né? But you can use your quick way or the shorter way of finding the distance CD, find the distance CB, and then use the area rule, and then you plus this, okay? But with that approach, you're gonna get an answer which is in decimals, but it should be very close to the 38. Okay, so that is 1.5. Okay, then 1.6, if TP is square root of 293, they want us to get the value of K. So we can use the distance formula, whereby we know that our K is bordered by which coordinates? It's K and -1, not so. K and -1. Then we have P, which is 6 and 1. 6 and 1. So P is saying is a 6 and 1, and then T is basically K and -1. So let's use the distance formula, whereby we know that our TP is going to be the square root of x1 plus x2 squared. It's not a plus, it's supposed to be a minus. Okay, x1 minus plus y1 minus y2, we square that. Let's do the substitution. So that's gonna be root 293 is equal to the square root. I'll say K minus 6 squared plus -1 minus 1 squared. Then I need to square both sides so that I get rid of the root sign. Okay, so 293 is equal to, open this, K squared minus 12K plus 36 plus, when I simplify that, I will get a 2, which is giving me a 4. So let's move everything to one side so that we get a quadratic. So minus 12K, this is a plus 40. And then 293, we subtracting the 40, we're getting 253 negative, okay? Minus 253 is equal to 0. You can use your quadratic formula or you can just use your factors. So this is gonna be plus 11. And then this is gonna be minus a 23. Okay, if I'm to really do that. But quadratic formula would make life a little bit easier, okay? Meaning that K should be a -1 or K should be a 23. But looking at the position of K on the Cartesian, we're seeing it on the negative side, meaning that K cannot be a 23, but rather a -11. So this is out. Okay, so that is what we would have done for that. Then 1.7, we must get the coordinates of E, whereby E is in the second quadrant such that ABCE is a parallelogram for 2 marks. Now, one thing we know is that whenever they ask us about a parallelogram, ABCE, and we need missing coordinates, the approach to use is going to be the midpoint. Okay, so with the midpoint, we know that the midpoint of this diagonal must be the same as the midpoint of the other diagonal. So for AC, since we say this was a 14 and a 4, 14, negative 14, meaning that the midpoint is at a 0. When you look at 0 and 4 divided by 2, so D is our midpoint. So this midpoint must be shared between B, E, and also A, C. So I'll put my X and Y here, and then apply the midpoint. So we say this was a 12 and 0. Okay, so what we're going to do is this format. Have to flip right and back and so on. So we said B is a 12 and 0. We're looking for our midpoint D is 0 and 2. And then we're looking for the coordinates of E, which is A and B. So let's apply the midpoint formula and say that 12 plus A divided by 2 must give us a 0. Cross multiply, meaning that our A is going to be negative 12. Then if we get 0 plus B divided by 2 must give us a 2. Our B should be a 4. That's all they needed. And then at 1.8, determine the equation of the line that is perpendicular to AC and passing through this point. So the only thing that we need will be the gradient of AC. Okay, what are the coordinates of AC? Let's see. Okay, we have AC, which is this, and we have the equation, okay? So the gradient of AC is 1 over 7. Okay, so we're saying the gradient of AC is 1 over 7, meaning that the gradient of the perpendicular should be negative 7, because we know that the product of gradients of lines that are perpendicular should give us negative 1. Okay, so if we have this, we have that point, then we can just substitute y minus y1 is equal to m into x minus x1. We simplify that, we shall say y minus 3 is equal to negative 7 into x minus 7. Open that bracket and see. So y is going to be negative 7x. That's going to be a plus 49 plus 3. So it's a negative 7x plus 52. This becomes our final answer. Okay, so that is to do with question number 1. 25 marks, done. We move on to question number 2. Question number 2. They're telling us that the diagram below, in the diagram below, we have a line that is a tangent to the circle. Okay, so I always prefer rewriting this line to something that is easier to work with. Okay, I'll write it as 2x plus 1 because I'm moving the y that side. Okay, so it's a tangent. Then Q, we have M, which is A and B. We have G, which is 2 and 5. And then the center of the circle lies on this other line. X plus y is equal to 9. Okay, then what do they need? They want us to get the gradient of GM. Now we're seeing that GM is perpendicular to this line, but we know that this line is having a gradient of 2. Remember what we said was that M1, like I will say gradient of GM multiplied by 2 should give us a negative 1. So gradient of GM must be a negative 1/2. I mean, you don't even need that working out for as long as you identify the gradient of the tangent. Okay, so that is done. Then they want the equation of GM. So we have the coordinates. Yes, let's use 2 and 5. Okay, we're using G, which is 2 and 5. So we're going to say y minus 5 is equal to negative 1/2 into x minus 2. Open up as you transpose. So negative 1/2, that's going to be a plus 1 plus 5. What will this become? It's negative 1/2 x plus 6. There we go. So that is 2.1.2. Then 2.1.3, they want us to get the coordinates of M. We know that M represents the center coordinates, okay? Now, we have the equation of this one. We said negative 1/2 x plus 6. we have the equation of this one, which is x plus y is that, meaning that we need to solve the two simultaneously to determine the x and the y, since the two lines are meeting just at one point. So I'm going to say that from the x plus y is equal to 9, y is negative a half x plus 6. So where there is y, I'll replace that. Okay, equation 1, equation 2, we can say substitute 1 into 2. So it's going to be x plus negative a half x plus 6 must give us a 9. Let's move the 6 that side. What's 1 minus a half? We're going to get just a half of x. Then 9 minus 6 is a 3. Cross multiply, it means that our x is what? A 6. So if x is a 6, y will definitely be a 3, because x plus y must give us 9. So 6 plus 3 should definitely give us a 9. So since they want the coordinates, we're going to say that m is going to be 6 and 3. All right, then hence or otherwise calculate the length of the radius. So with the radius, we know that we have our coordinates m, 6 and 3. We have g, which is 2 and 5. So let's get the distance gm. Okay, I'll omit the formula and just say x minus x1, so 6 minus 2 squared plus 3 minus 5 squared. Okay, so when I punch this into the calculator, that's gonna be 4 squared plus plus 4, which gives me 2 root 5. Okay, so the radius is basically 2 root 5 units, since it is a measurement. Then write down the equation of the circle in this form. So we need to start by rewriting the general expression. So x minus a squared plus y minus b squared must give us r squared. So we know that our m was a 6 and what? 6 and 3. So it's going to be x minus 6 squared plus y minus 3 squared, and then is equal to, we said 2 root 5. This is squared. Okay, we open this up. It's going to be x squared minus 12x plus a 36. That's going to be y squared minus 6x plus a 9. It should give us 5 and 4, which is a 20. Okay. Then I'll just regroup into the format they want. So I have my x squared plus y squared minus, I have 12x. We are subtracting, oh Lord, why am I saying x here? It's supposed to be y. You have x, isn't it? So minus 6y. And then we know that 36 plus 9, that's going to be a 45. We subtract 20, it's just going to be a plus 25, should give us 0. So that is what we have to do with 2.1.5. Then 2.2, determine the equation of the inverse of the tangent to this circle at this point. Give your answer in the form of mx plus c. Hey. This question, and then they give us a full page. Our examiners. Okay, let's see. So step number 1. Okay, so we are assuming that there is a circle here. This circle has a tangent, and the tangent is at 7 and 2. So one thing we need to first of all determine the coordinates of the center, get the gradient of the radius, okay? And then from the gradient of the radius, we can find the equation of the tangent. Then after getting the equation of the tangent, then we can proceed and look for what the question is asking for, which is the inverse. So for us to get the center coordinates, we need to complete the squares there. So it's going to be x. This is minus, né? So minus a half of, why don't I just start by, no, I don't want to lose people. Let's say x squared plus y squared minus 26x plus 12y is equal to negative 105. Let's put it that way. Okay, so with the x, I'll say x minus half of 26 is 13. I'll square that. On this side, I'll have my 105 plus, what is 13 squared? That's 169. Eh? Then plus, with the y, I'll say y, this is a plus here. A half of 12 is 6. I square that. But I know that 6 squared is going to be 36. Ne? So I'll end up with x minus 13 squared, and then y plus 6 squared is equal to, what is negative 105 plus 169 plus 36? I'm getting 100. Okay, so we know that our center coordinates, let me just call them M for the center, will be 13 and negative 6. Okay, so if it's 13 and negative 6, I have to go ahead and get the gradient. Okay, so the gradient of the radius. So change in y over change in x. So we have this and then 7 and 2. So I'll say 2 minus 6 over 7 minus 13. So that's going to be 8 over negative 6, which becomes 4 over 3, but negative. So that's the gradient of the radius. Then we know that the radius and the tangent are perpendicular. So the gradient of the tangent is going to be a 3 over 4, because negative 4 over 3 times gradient of the tangent must give us negative 1. Okay, so if we have our gradient of the tangent, let's get the equation of the tangent. Okay, equation of the tangent. Remember, we said y minus y1 is equal to m into x minus x1. So I'll say we're still using 7 and 2 as our point of interest. Is that correct? Awesome. So we're going to say 7 minus 2 is equal to 3 over 4 into x minus 7. Let's open up and see. Minus 2 is equal to 3 over 4x minus 21 over 4. Let's move the 2 to that side. So it's going to be 3 over 4x. And I look at this, we have negative 21. 21, not 12, okay? 21 over 4, we are plusing the 2, which means we have negative 13 over 4. So this is the equation of the tangent. But what is the question asking for? Equation of the inverse. Now remember, when you're looking for the equation of the inverse, you just switch. Okay, what is x is y, what is y is x. So meaning this is our x, 3 over 4y minus 13 over 4. Let's move the 13 over 4 that side. So we're going to have x plus 13 over 4 is equivalent to 3 over 4y. Okay, then divide both, or divide through by 3 over 4, or multiply through by 4. So 3y is going to be 4x plus a 13, then divide by 3. So it's 4 over 3x plus a 13 over 3. I mean, why the 7 marks? Guys, it's a lot. Yo. For 7 marks. We move on, guys. So that is question number 2. Question number 3, which is the trig. Okay. So with the trig, they are telling us that tan beta is a 3 over 4. Okay. But beta is between 180 and 270, meaning that we're focusing on quadrant number 3. Okay. 0, 90, 180, and 270. So this is our quadrant of interest. Now, if we have quadrant 3, we know that in this quadrant, tan is positive, but tan is given as the opposite over the adjacent. So our opposite is this, our adjacent is that. But now we're seeing that the 3 and the 4 are both on the negative side of the axis, okay? So if that is O, I can call this a T, and then maybe M. So the first thing I need to do is look for the hypotenuse and say that my OT is going to be negative 3 squared plus negative 4 squared and the square root. The reason, that is the Pythagoras. Okay, so meaning that our OT is just going to be 5 units. So if that's a 5, they want the sine of beta. Sine of beta is opposite of hypotenuse, which is negative 3 over 5. Then we move on. They want us to simplify 2 minus sine to beta. So it's a double angle of sine. It's going to be 2 minus 2. This is sine beta cos beta. Okay. Do we need to factorize? No, we don't need. So it's 2 minus 2 times sine of beta. We said it's a negative 3 over 5. Cos of beta. Okay. Cos is adjacent of hypotenuse, so it's negative 4 over 5. Okay, let's try to simplify this and see. So it's a 2 minus, because this minus here and the minus there is going to give us a positive. Né? So that's going to be 8 times 3, which is a 24, over 5 times 2, which is a 25. Okay, when I punch this, did they say without a calculator? That's what they said. But it's fine. We can just subtract this. We know that 2 times 25 is 50. Okay, 50 minus 24 is going to be a 26 over 25. But even if you punch this in the calculator, I mean, there will be no harm in that since we've just simplified all the rest. The essence of not using a calculator is for you to find the size of beta. All right, then 3.1.3, we have cos squared beta, cos squared of 90 minus beta minus 1. So this just looks otherwise. Okay, what I need to do is take out the negative sign so that I have 1 minus cos squared of 90 minus beta. I know that 1 minus cos squared gives me a sine squared. So I'll be left with sine squared, but of 90 minus beta. Okay, so this is still in the bracket, but now these are complementary angles, okay? So with complementary, if I'm looking for the sine of 90 minus, my result should be a cos, okay? Meaning that our answer is going to be cos squared of just beta. Then I go back to the question and look for the cos. Cos is negative 4 over 5, okay? So negative, we have negative 4 over 5. This is squared. So it's a negative 16 over 25. So that is what I'm getting, guys. Please liberate me if need arises, okay? So we move on to 3.2, evaluate. So whenever a question asks you to evaluate, they just want you to find the value. They want you to simplify that question and find the answer if possible. Okay, so we have negative 1 plus cos 180 minus theta, sine of theta minus 90, and so on and so forth, okay? So with the bottom part, I'm not seeing any problems, okay? But the top part, I feel there's some work to do. Number one, we need to take out the negative here so that it is a 90 minus theta. With this 540, 540 is just a multiple of 180, because if we get 3 180s, then we have the 540. So I'll treat this as a 180 plus. Okay, so negative 1, cos of 180 minus, in second quadrant, cos is negative. So it's going to be negative cos of theta. I'm multiplying it by, since there's this negative, it must come out. So it's going to be negative. Sine of 90 should give us cos of theta. This is all over. Cos of negative is the same as the cos of positive, so that negative has no effect. Then the sine of 90 plus should give us the cos. Okay, we're multiplying it by, we know that 180 plus is quadrant 3. In quadrant 3, tan is positive, so that's going to be tan squared of theta. All right, so let's look at the top part. It's going to be negative 1. This negative and negative will give us a positive cos squared theta over, this is going to be cos squared theta. We know that tan squared is the same as the sine squared theta over the cos squared theta. I'm addicted to excess. Oh, Okay, so let's simplify that. One thing that I'm seeing on top, I can take out the negative sign, okay? So that I have 1 minus cos squared theta. I'm dividing it by, this is going to cancel that. I have my sine squared theta. So from our identities, I know that 1 minus cos squared must give us sine squared. So it's going to be negative sine squared theta over sine squared theta. Cancel that out. You get a beautiful -1 as your final result. For 7 marks, at least here, they are generous here. I concur with them. I agree, strongly agree. These are the marks that someone deserves. 7 marks. Okay, then 3.3, they want us to prove this identity. Now, whenever we're proving identities, we are advised to always start from a side with more items. And in this case, I believe either side would work perfectly. Okay, so I'm going to start from the left-hand side. So with the left, I need to open this square bracket, meaning that I'll have my sine squared theta minus 2 sine theta cos theta plus cos squared theta using the FOIL, over 1 minus sine squared gives us a cos squared. So I've started collecting some marks from the expanding and then applying the identities. But I know that this and this should give me a 1. Okay, that must give me a 1. So meaning that I have a 1 minus. Do we need to take this double angle? No, it's gonna be a lot of work. So let's leave it the way it is over cos squared theta. Let me split this up. So I have 1 over cos squared theta minus 2 cos theta sine theta over cos squared of theta. So this is already here. We have it. So our problem is just whatever is left. So the 2 is here. Perfect. So 1 cos goes with 1 cos. So we're left with just a sine over cos, which is a tan. Beautiful. So 1 over cos squared theta minus 2 tan of theta is equal to the right-hand side. All right. So that is how we would have also collected those 5 marks. Okay, question number 4.1. We're given cos of A minus B is given as that. So we're given the compound angle identity. And then they want us to use the above identity to deduce this entire expression. So then the question is, how do we arrive at the sine of A plus B if we have the cos? So one thing we can say is that we need a 90 plus. So we're going to say that the cos, okay, and then I'll have 90 minus our A plus B. So if you simplify this or reduce this using your compound angles, you're going to get a positive sine of A plus B. Then I'm going to detach this A, and I have a cos, let's say, of 90 minus A. Okay, and then I'm going to subtract a B. That's how it is. I'm opening up this bracket. Now, if I treat this as one angle, then I'll have that minus. Then I'll open up this using the rule that I was given. Always use the 90 minus. So that's going to be cos of 90 minus A, and then the sine of B. Then this is going to give us, it's a minus, so we must plus, the sine of 90 minus A, and then the sine of B. Then let's use our complementary angle identities. So cos of 90 minus is giving us the sine of A, and that is the sine of B, plus sine of 90 minus gives us the cos of A, and then the sine of B. So this is what the question just wanted us to do. All right, then 4.1.2, hence or otherwise determine the general solution. So we're not looking for definite angles, we just need the solutions, okay? So first things first, I'm seeing a 48 and a 15, a 48 and 15. Let me move this to that other side. So that I have the sine of 2x plus 50 is equivalent to the sine of 48 cos of 15 plus sine of 15 cos of 48. Meaning that our sine of 2x plus 15 is equivalent to, this is now a compound angle of sine, which means we have a 48 plus 15 because of that sine. So we know that 48 plus 15 gives us a 63. Okay, this is going to be sine of 63. Now, given the fact that we have just the same trig ratios, okay, on the right and on the left, we can just ignore the ratios and focus on the angles. So with the first angle, it's going to be 2x plus 50 should give us 63 plus 360 times k. And then we simplify this. We need to move the 50 that side. So 2x is going to be a 13 plus 360 times k, then divide through by 2. X becomes 13 over 2, which is a 6.5 degrees. Okay, the degrees, yeah, okay, plus 180 times k. Don't forget k is an element of integers. Now, this is the first quadrant, okay, where sine is positive. Then the second quadrant where sine is positive, we're going to have 180 minus that angle, okay? So 180 minus 63, it's 117, perfect. Meaning that I'm going to have 2x, okay, plus 50 is equal to 117 degrees plus 360 times k. Let's move the 50 that side. Okay, so we're saying 117 minus 50, it's giving me 67 plus 360 times k. Then let's divide through by 2. So x is going to be, what is 67 divided by 2? That's a 33.5. Okay, plus 180 times k. K is an element of integers. So basically, that's all we had to do to get those 4 marks. Then if cos of x plus 30 is equal to negative 2 sine x, can we deduce that the tan of x is given as that? Okay, deduce, proof. Okay, so what we're going to do then, let's do the compound angles again, okay? Open up that. So that's going to be cos x, cos of 30, minus the sine of x, sine of 30. This one we can, it's fine, let's leave it that side, negative 2 sine x. Okay, then we need to use our special angles. Okay, so we know that cos of 30 is the same as root 3 over 2. Ne? So you're going to have a root 3 over 2 multiplied by the cos of x minus sine of 30 is a half. Sine of x is equal to negative 2. But why am I doing this? I'm just prolonging things now. Let me move this to that side since they are like terms. So root 3 over 2 cos x is equivalent to minus 2 plus a half, which becomes negative 3 over 2, but sine x. Now, one thing we know is that we have both denominators being 2, so this will cancel that. And then we're going to have, since we need a tan, we need to divide this by cos x and then by cos x. But now, since I want one tan, let me just divide by negative 3. Okay, so that this cancels that. Then I have my tan x here. And then this cancels that. Then I'll have a root 3 over negative 3. Okay, so that's basically what the question wanted. Okay. Now someone will say, but now it's not in the same form. Remember, this negative 1 over root 3. If you rationalize it, it's root 3 and then root 3. So that's going to be negative root 3 over 3. So this is what the question wanted. So therefore, we're saying tan x is negative 1 over square root of 3. Okay, so that is that. Then 4.3, we're given this expression. They want us to simplify it into a single trig ratio. Okay, so what we do here, a single trig ratio. What do we see? What do we see? I'm seeing a double angle identity on top, same as at the bottom. Okay. So if I look at 2 multiplied by 2 sine x cos x, I'm going to take out the negative and then I'll have 1 minus 2 sine squared x. Is that correct? If I'm to follow let's look at the formula page, which I hardly use anyway. So it's saying it's 1 minus 2 sine. Okay. 1 minus 2 sine. Where are we? We are here. So it must be 1 minus 2 sine. Okay. So that's going to be our first part. So it's going to be 2 multiplied by the sine of 2x over, it's going to be negative. This is going to be a cos of 2x. Simplifying that, we're going to end up with just negative 2, but tan x. Okay. Then for which values of x, okay, in the interval between negative 90 and the 90 will the above expression be undefined? So it's a two-way thing, okay? You can look at this bottom part, which is the cos 2x. Where do we find cos 2x to be undefined? Okay, so if I'm looking at a 90, we know that the cos of 90 gives us a 0. So meaning that it's not going to make sense. Let's see the cos of 180. It's going to be negative 1. So let me focus on the tan. So if I have a graph of tan, okay, this graph, if it is to be drawn, when x is negative 90, the graph is going to be undefined, okay? And then when x is a 90, the graph is also undefined. In other words, it will not touch those points. Those points will be basically asymptotes. Now they're asking us for which values of x within this interval. Now, the fact that we're focusing on intervals that are not inclusive, we can just draw a conclusion that no values of x. That's what I'm thinking, because it is only undefined at this and that. But when you talk of the intervals in between, then there are no values. There are no values at all. Okay, then 4.3.3, without using a calculator, simplify this. These questions. But this one looks more or less the same as what we just dealt with. So it's going to be 2 multiplied by 2 sine 15 cos 15 over negative, we said 1 minus 2 sine squared 15. Okay, so we said this is going to be 2, but I was supposed to use the tan directly. Oops, okay. So let's say 2, this is going to be sine of what? Sine of 30 over, this is going to be cos of 30. It was supposed to be just a direct part, whereby we just substitute into this 2 negative 2 tan something. Okay, so that's a negative. So we know that the tan of 30 is opposite, which is 1, over the adjacent, which is a root 3. So meaning that our answer should be a root negative 2 over root 3. Okay, so that is what we would have obtained for 2 marks. Then question number 5, which is the trig functions. Okay. So with the trig functions, they're asking in the diagram below, the graphs f of x are that, g of x is that. Now pay attention to the brackets. There are brackets here. There are no brackets there. Okay. Then they're asking us, okay, we have the turning points and they're telling us that A is the x-intercept of f, which is 6, 10, 0. Okay, makes sense. Can we determine the values of m and n? Now with m, okay, so this m is just a shift. A normal course graph must be passing at 1 for as long as the amplitude is 1, must be passing here. But now there's a drop by a half. to down. So meaning that our M is going to be negative a half, or someone can say negative 0.5. And then with the N, we know that a normal sine graph, which is the G, must be passing through the origin here. But then in this case, it's not happening. There's a 30-degree gap in between, okay? So meaning that this graph was shifted 30 degrees to the right, ne? 30 degrees, is it to the right or to the left? To the left, 30 degrees to the left, meaning that our N is going to be a positive 30. Okay, so if that is true, then they want us to write the amplitude of F. So with F, remember, for us to get the amplitude, we can just get it from the graph itself. What is the coefficient? Of course, it's just the 1. Okay, so the amplitude is a 1. Alternatively, get the maximum minus the minimum divided by 2. So our maximum is 0.5. Our minimum is negative 1.5. Okay, divide by 2, you're still going to get a 1. Okay, then 5.3. If h of x is the same as g2 of x, can we write down the period? Now, initially, okay, when you look at the g of x, this x is having a coefficient of 1. Now we are introducing a 2. So this 2 will affect the period. So initially the period was 360, but now it's going to be 360 divided by 2, which becomes 180. Okay, then 5.4, for which values of x will f of x, g of x be less or equal to 0? So two scenarios, positive, negative, negative, positive. So one graph should be above while the other one is below. So let's start with the G. G is above while F is below, around this area. Okay, around this area. This one is above while the other one is basically below. So in that case, our interest will be the 60 and this value here, which is 150. Okay, is there a scenario whereby F is above and G is below? F is above, G is below, but it is on the left-hand side, which is not part of the solution set of interest. So what we're going to say here is that 60 degrees should be less or equal to X, less or equal to 150 degrees for 2 marks. Then 5.5, describe the transformation Z. Okay, so it's more than one transformation that is taking place. For the graph to undergo to form P of X, which is this. So it's G that we are playing around with. Initially, it was the sine of X plus 13. Now, step number 1, how do we change this graph into a cos? That should be the first transformation. So number 1, we need to plus a 60 here so that it is a 90 plus X. If that is true, then we're going to get our cos what? Our cos X. Now, if that is happening, we're shifting the graph 60 units or 60 degrees to the left. Okay, then after getting our cos of X, then we can flip it around. We reflect it around the x-axis. Then we have the negative aspect of it. So number 1, we're going to shift the graph 60 degrees to the left, and then reflect it about the x-axis. So those are the two transformations that they wanted. We move on to question number 6, which is the application of the trig or the 2D trig. In the diagram below, AEBD is a horizontal plane, okay? We have a vertical pole, the angle of elevation, A to the top, is equal to X. And then this angle is 2X, that's a 90, and then those two sides are equal. Can we prove? How many marks is 6 marks? Okay, it's what? It's what? Okay, so step number 1. Since our focus is AD, which means the triangle of interest is this one. We know that this is the same as that. So we need to find what AB is. So let's start by expressing AB in terms of H and X. So we can use tan and say that the tan of X is going to be the opposite over AB, meaning that our AB is going to be H over the tan of X. Okay, so that is equation number 1. Then we can use the second triangle to say that the angle DAB is also the same as DBA, which is going to be, reason is going to be angles opposite equal sides. So for me to get that, I'll get my 180 minus 2x divided by 2, which is just a 90 minus x. Okay, so this is a 90 minus x. This is also 90 minus x. Then let me use the sine rule. So the sine rule is going to be AB over the sine of 2x is equivalent to AD that I need over the sine of 90 minus x. So let's make AD the subject. So AD is going to be AB, the sine of 90 minus x divided by the sine of 2x. Okay, let me just simplify this. So we have our AB as h over tan x. Okay, so that's going to be h over tan x. This sine of 90 minus going to be a cos x. Let's split the sine 2x, which is going to be 2 sine x cos x. Then let's cancel what needs to be cancelled. So this cos cancels the cos, and then that's what we have. So it's going to be h over 2 sine x, and then the tan of x. So that is our AD. Isn't that what the question wanted? 2 sine x, tan x. Perfect. Question number 7. 7.1, PQRS and T. All of them are lying on a circle with center O. PR is perpendicular to OQ. And then these two lines intersect F. Pot is a straight line. P1 is a 42. Must give reasons for R1. So what is R1? So this is a 90 because this is a diameter. Ne? So you're going to say that our R1 is a 90 angle in a semicircle. Angle in a semicircle. All right, so if that's a 90, we need to look for S. Where is S? S is here. So I can look at PRST as a cyclic quad. So meaning that our S is going to be 180 minus a 42. So 180 minus 42 gives me 132. The reason is going to be the opposite angles of a cyclic quadrilateral. Okay, so opposite angles of a cyclic quad. Okay, so having obtained the 138 here, are we going to need it? Not really. Just answer the question. Okay, then we need to move on to the next one. We need to find PQR. So they're saying P, Q, and R, this entire angle down here. So what we need to do there, we need to start by looking at PQRT as a cyclic quad of its own as well. So in that case, I need to find the angle T2. So how do I get T2? Focus on this triangle here and then get the T2. So I'm going to say that T2 is going to be a 90 minus 42, which gives me a 40, I think it's a 48. No? Yeah, T2 is a 48. Reason angles in a triangle, or remaining angle of that triangle. So if that's a 48, meaning that our PQR is going to be 180 minus 48, which becomes a 132. Reason opposite angles of a cyclic quad. Okay, we have plenty of cyclic quads there. Then if PR is a 7 and QR is a 4, you need us to find QF. If PR, okay, meaning that from here up to here is a 7, and then this is a 4. So if this is a 90, we know that this is also a 90. But now we need to start by saying that RF is the same as PF, which is going to be like 3,5, a half of 7. So 3,5, 3,5. Reason, line from a center or the perpendicular bisector of a chord from a center must bisect the chord. Then we can focus on the theorem of Pythagoras there and then look for our QF. So we're going to say that QF is going to be the QR squared, okay, minus the FR squared. So that is 4 squared minus 3,5 squared. Oh, must be under square root. Ne? So when I put that under the square root sign, what am I writing? 1,94 units, because I got root 15 over 2. I don't know if that makes sense. Root 15 over 2, which is 1,94. Okay, so that is to do with that question. Then we move on to 7.2. By telling us the diagram below, B, D, and C lie on the circle with center O. AB, AD, they are tangent to the circle at B and D respectively. We have a 59. Wow. They want us to get B1. So before we get the B1, we need to remember that if these are tangents from a common point, these tangents are going to be equal to each other. And if they're equal, this angle B1 must be the same as D1 because that's an isosceles triangle. So we're going to say that B1 is equal to D1. Angles opposite, equal sides. Ne? Then we're going to say 180 minus 59. 180 minus 59 gives us 121. Divide this by 2, we get a 60,5. So that is what the question wanted. But now for 4 marks, someone can still say that AD is equal to AB. Okay, AB is equal to AD. Tangents from a common point. Tangents from a common point. And then we can write that down. I think we are good to go. All right, then they want us to get O1. O1. So he's saying this is a 60,5. That's a 60,5. They want us to find this O1. So I know if that's a 60,5, even C is going to be a 60,5 because that is a tan chord. So I'll start by saying that C is a 60,5 is because of the tan chord theorem. Okay, if that is true, we know that O1 is the angle at the center and then C is the angle at the circumference. So O1 is going to be twice of C, which is 2 times 60,5, which gives us 121. Reason, angle at the center must be twice angle at the circumference. Forgive my handwriting. Forgive my handwriting. Okay, so that is that. Then we move on to question number 8. In the diagram below, A, B, C are points on the circle with center O. They want us to prove the angle at the center theorem. Okay, how many marks is 5 marks? Not bad. So step number 1, okay, you construct. Okay, please do your construction neatly and nicely. T. So you can tell us that construct the line BT or extend the line BT, no problem. Then label this as 1 and 2. This is 1 and 2 as well. Then you're going to start with, let's say, triangle. I'm saying from OBC. I know that O2, this angle here, is going to be B2 plus this angle C. Reason, those are exterior angles of a triangle. But we know that B2 is the same as C. Angles opposite, equal sides, ne? Because this is a radius and that's also a radius. So those two must be equal, meaning that our O2 is going to be twice of B2. Call that equation number 1. We move on to the triangle. So it's saying from triangle BOA or AOB, we can say that O1 is going to be, let me not do that. So being 2 forward. Say B1 plus A, exterior angles. And then we're saying that B1 is the same as A, angles opposite, equal sides, okay? So meaning that our O1 is twice of B1. Call this equation number 2. Then you need to plus the 2. O1 plus O2 is going to be the same as twice B1 plus twice B2. But O1 and O2 is the same as AOC is equal to twice B1 plus B2. Therefore, AOC is the same as twice B. All right, so that is what was meant to be done for those 5 marks. Then question 8.2 in the diagram below, BC. Where is the BC? This one is parallel to this line. C3 is X, this is our X, and then these ones are other lines that are drawn. You can't just say other lines that are drawn. Be specific. They look like tangents as much as they say other lines are drawn. Anyway, the fact that they are coming from one common point and they are touching the circle at one point, I'm going to presume that these are tangents. Okay, because the question seems vague if they just say lines are drawn and then they look like tangents. Okay, so what I can do to get the 4 angles of interest, I can see that, remember, I'm assuming that these are tangents, né? So this angle is going to be the same as this angle B. So B is X, and I'm saying is the tan chord. Okay, so if that is X, it simply means that even F2 is going to be X. The reason being, those are corresponding angles because FD is parallel to BC. We have two to go. If this is X, meaning that E is also going to be X, this one. Reason it can be a tan chord, okay? Or we can use the bow tie, angles in the same segment. So is X, we're saying it's a tan chord, or angles in the same segment. Remember, you can just use one reason. Then if that is true, that this is X, then we have A3 to also be X. Angles opposite, equal sides. Why are they opposite equal sides? Remember, this is a tangent, this is also a tangent from a common point, so they have to be equal, and if that's X, this must also be X. All right. Or you can use the tan chord using this and that, no problem. Then can we prove that AFCD is a cyclic chord? So with this, we don't have any angles that are dealing with numbers, so we need to focus on the properties. AFCD. So AFCD. So what we can see is that this is forming our bow tie again. Okay, so this angle is the same as that. That's enough. We draw the conclusion. So it's saying F2, okay, is the same as C3. Therefore, AFCD is a cyclic chord. Reason is going to be the converse of angles in the same segment. Okay, that's one other proof for the cyclic quadrilaterals. Then 8.3, in the diagram below, AC is the diameter, the circle with O as a center, AC is produced to P, B1 and B2 is 127, P16. Can we prove that BP is a tangent? So for us to get BP as a tangent, okay, we just need to make sure that our B2 is the same as A. That is the trick of this question. If we can prove that B2 and A are just the same, we are good to go. Okay, so I'll start by looking at the big triangle and find the size of A. Okay, so I'll say that my A plus 127 plus 16 must give us 180 degrees. Those are angles in a triangle. Then now A is going to be 180 minus, what's 127 plus 16? That's 143. Okay, so 180 minus 143 gives me a 37. So this is a 37. So if A is 37, I need to say that B1 is a 90. Okay, angle in a semicircle. Then for us to get the B2, it's going to be 127 minus 90, which is also a 37. And then we're going to say that since A is the same as B2, therefore BP is a tangent. The reason is going to be the converse of the tan chord. All right, so that is that with question 8. Question 9, remember the paper had 9 questions, eh? So this is question 9, the last one. The diagram below, PQ is the same as QR, same as RS, but VR is parallel to TS. So let's determine the value of TV over VP. So one thing we need to know is that TV over VP is going to be the same as RS over RP. So if this was X, okay, just assuming that was X, this simply means that our TV over VP is going to be RS, which is 1X, over RP, which is like 2X's, meaning that that is going to be a half. That's what I'm getting. Then for the next one, determine the value of the area of that. So we're looking for the areas. Now with this, I'll say that the area of PQV, okay, PQ and V. Now I'm also looking at the area of PST, P, S, and T. So let me assume that that is my height or my base and so on and so forth. How are we going to deal with this? Okay, so it's a PQV and a PST. Okay, so I'll say a half multiplied by my base multiplied by the height of a half, a base, and also the height. So the only thing that is changing will be the bases, that our PQV is just X, then same height. And then this other one is going to be 3X's, then the height is that. Is that really for 5 marks? Okay. So half cancels a half, the H cancels H, and then I'm just going to be left with a third. I'm not so confident with my answer there. Okay, but we move on. Question 9.2. In the diagram below, B, C, D are points on the circle. ADC is a straight line. AD is a tangent. Can we prove that the two triangles are similar? Okay, so for us to prove similarity, one thing we know is that this angle here, B1, is the same as this angle C. That's a tan chord, okay? But we know that A is the same as A, which is common, okay? Meaning that our D1 should be the same as B1 plus B2. That is basically the remaining angle of a triangle, remaining angles of a triangle. So if we have the three statements, therefore, CBA is similar to BDA. Angle, angle, and angle. Okay, so that is done. Then 9.2.2. They want us to prove this. Now, I'll just start by kind of sketching. I'm sorry, but I love sketching. So if this is our small triangle, which is A, we're saying a B1 and then a D1. And then we have our big triangle, which is A together with a B and then a C. And what about the size? Sometimes the size is misleading. Just want to see which sides or which angles are in proportion. Okay, so meaning that if I have this AB over the AC, it should give me the same as AD over the AB, which must also give me the BD over the BC. But with our question, we don't have BC, we don't have BD. So I'm going to cross that out and just focus on these two. Okay, so I'll start by writing this statement and then I'll give the reason that our CB, it was a CB what? It was CBA. CBA being similar to CBA being similar to BDA. Okay, then let me cross multiply. So I'll have my AB squared is equal to AC multiplied by AD. But the question still doesn't have AC, okay? But when we look at the big triangle, we're saying that this AC is a combination of the two. So AC is AD plus DC. So I'm going to replace AC with that. Okay, so it's gonna be AB squared is equal to, I'll say AD into, we said AC is going to be AD plus DC. Open that up. So ABC squared is going to be AD squared plus our AD times the DC. Let's move this one that side. So AB squared minus the AD squared should give us the AD times the DC. Isn't that what the question wanted? AD DC should be equivalent to AB squared minus AD squared. Perfect. So this is what the question wanted. And that is where we stop. Additional space, we don't need it. All right, guys, thank you very much for listening and watching. Please, if any issues, please, you can slot them in the comment section. If you've not subscribed, please go ahead and subscribe, like, share, comment, and we appreciate your feedback that you give us. That makes us a better channel that we are. All right, guys. So out of 150, okay, to my rating, I'll give it a 145. Okay, 145 with a percentage. Yeah, it was shaky. It was a bit tricky, but it was still doable. Okay, it was still doable. So, guys, I wish you the best in all your remaining exams. Let's meet again when the time is right. Bye-bye for now.